This video teaches you how to use Brightstat for the assignments in this course. You can also use Brightstat for your projects. To get to this screen, you go to brightstat.com. You can use my account. The password is Research301, which ought to be easy to remember. It's the number of the course and it's the name of the course, Research301. So let's log in and see what we get. The first screen is how to upload your data file if you were working on your project. I've already uploaded my file. If your data is in an Excel file, you can load it directly into Brightstat. You can't have any spaces in any of the cells, and you shouldn't really have any commas in any of the cells because it tends to confuse Brightstat. So there's a separate handout on how to clean your data to upload it. Let's go right to the web app. The reason I like this program is not just because it's free, but because it works on an iPad, your cell phone, if you don't mind turning on the magnifying glass. It works on a Macintosh, it works on a PC. It's agnostic when it comes to the platform that you choose to use it on. The first thing you see are all these red buttons. Honestly, the first button just makes the screen slightly larger. The second button enlarges the print or the type in case you really are doing this on your cell phone. I'm recording this in late April 2015. This program came out 2 weeks ago. At the bottom of the screen are these three buttons. There's the data screen, the variable screen, and the output screen. If you were doing statistical analysis in, say, an expensive program like SPSS available at the library and in the business building, I believe they have it on all their computers over there. Instead of choosing buttons, you just have different screens. Brightstat, other than the home screen, which is behind the screen you're looking at right now, it's kind of a one-screen app. So let's go in and do the work. The first thing you have to do is download from the server where I uploaded it. You have to download it and get it into the workspace that the program uses. So you click on Download from Server. You click on Please select your file. So when I click Load, I believe you can drag it on the iPad. It takes a long time to load. It's moving a lot of bits and bytes, bouncing off satellites. It doesn't take several minutes, but it does take an uncomfortable amount of time to appear. And there are only 5 variables: fear of speaking, experience speaking, education, age, and gender. But that's for student number 40 in a 40-member class. I always use the alphabet, so if you're Adams, you're probably, or Abraham, you'll be number 1, which means you have to scroll all the way over to person number 1. And if your name is Williams or Zimmerly, you might be clear at the other end of the class. Most of my classes don't go up to 40. So we're going to do all this demonstration with person number 40. You need to report the mean, the standard deviation, and the range, that is the minimum and maximum values that determine the range, for each of your interval level or ratio level, higher level measurement data. It's fake data, but if this was real data, in the method section of your project, these are 30 people. If you scroll through the list, there's 30 different people. It even says down at the bottom, showing 1 of 30 entries. Your data would be real, and you would want to describe it in your method section. All quantitative research describes interval level data or ratio level data as the mean, the standard deviation, and the minimum and maximum values. By the way, this other button down here, variables, just shows you all the variables here. It goes up to 199 because it starts with 0. Why are there 200? Because this is a list of 5 variables for 40 different students. The output screen shows you the results of your work, and it's blank right now because you haven't done anything. So let's do something. Let's go up to the top menu, which sometimes is called, as it is here, the output menu. If we went to the data screen, it would be called the data menu. And we choose the descriptive statistics. Why descriptive? Because for interval and ratio level data, we need to compute the mean, the standard deviation, and the range. You also will need frequencies for gender because there'll either be so many men and so many women and so many people who chose not to answer because they identify differently. The frequencies are just a percentage, so you have to do these separately. Don't report frequencies for variables that are interval level. And definitely don't give me the mean and standard deviation for male and female because it's complete nonsense. You just need percentages. So let's do it. Click on descriptives. Say you're person number 40, you would choose the variables that are ratio. Age is a ratio level variable. These others are interval level data. We're going to choose those and call them our selected variables. Why didn't I choose gender? Because it's not, you can't average male and female. On an iPad, you can point and drag these over there. I tried it one day and it seemed to work. You need the mean and the standard deviation. You can turn off the standard error. This assignment doesn't ask for the standard error. You just need the mean, the standard deviation, and you also need to report the minimum and maximum values, which determine the range. Don't click on range. The reporting of the range is all about where did it start, where did it end. All you have to do then is click on OK. You just go back up to the output menu and you choose frequencies so that you can go do gender. Click on gender or drag it over with your finger if you have a touch screen. Click on OK. In your projects, you would not put this into a table. You would put it into a sentence form. For gender, you would put it into some form of a sentence in your project. In addition to filling in the blanks for the methods section of Module 5, we now need to go see how to get the information to fill in the results section for Module 5. For correlations, we pull the menu down, and under the Analyze column, we choose Bivariate Correlations. We're going to be correlating fear of speaking and experience. Again, for person number 40. Check Pearson. Pearson is normally a two-tailed test. If you ever had to do a one-tailed test, you would check this box. Click OK. That's how easy it is to get a correlation. You'll see that R is equal to 0.18. You always round to the nearest hundredths place. The value of T should always be ignored. Pearson's is an R value. When you report Pearson's in a sentence, in this case you would say that fear of speaking is not correlated with experience. The reason it is not is because P is not less than 0.05. You also report the degrees of freedom, which is 28. Why 28? Because you have to subtract off one number for each of the two variables. So 30 minus 2 equals 28. This is how it would look in a sentence. In these other procedures, you don't have to compute degrees of freedom. Let's go do those. One of them is called t-test. And there's no choice here called t-test. So you have to know that in a t-test, you're comparing the mean of one group to the mean of another group to see if they're different. When we did the correlation, we just wanted to know, are the two variables connected or related or associated with each other, which is different than a difference test. So click on Compare Means, and you get all these choices. I want you to do a t-test for independent groups, male and female. So you would do the t-test with the second red box. And when I ask you to do the ANOVA, you'd use the third red box. Why not this ANOVA? Why not this t-test, the fourth or fifth one? Because those are for when you repeat the same sample or you repeat the same procedure. Why not this first red button? It seems the easiest one to reach. It's at the top of the list. I bet it's the one I'm supposed to use. No, that's when you're comparing not two groups, but you're comparing one group to the hypothetical population. Let's click on the second one. And it takes me to a screen called Two Independent Samples t-tests. You have to have numbers only as variables, so you can't put words in. Someone said, strongly agree, you'd have to convert that into a number for it to work. Let's do fear of speaking as our dependent variable. Our independent variable for comparing two groups. Which of these would make a nice two-group variable? I'd say gender would be perfect because generally gender is one or the other. In order to enter this variable, you have to select it over here on the right-hand side of the screen. You find gender for whatever person you are alphabetically in class. It fills in the values. I click on OK, and I get a lot of confusing numbers here on the screen. As simple as a t-test is, it looks complicated. The important thing about reporting the results in the results section of your projects is that you report the mean and the standard deviation for the men and the women in a sample sentence. What's Levine about? Levine just wants to make sure that the two groups are comparable. It's beyond the scope of this course. If you're here for extra knowledge, I'll just tell you that when you go down to the bottom of the screen, I want you to use the top t value. The only time you would use the second t value would be is if Levine was a significant value, which it's not. P is much too big. You would want to take note of the value of t, which is 1.14, the degrees of freedom, which is 28, and the two-tailed value for p, which is the probability you've made a type 1 error. It's 0.26. You would report it in a sentence. Again, a very long sentence. Males, m equals 65.33, standard deviation equals 27.17. Did not differ from females, m equals 53.33, standard deviation equals 29.73. And then you put the values for the t-test. T of degrees of freedom 28 equals 1.14, comma, p equals 0.26. Let's hurry now to the ANOVA. The ANOVA is not too bad. You can either get into it through the ANOVA or you can get it through compare means. I like compare means, so let's just go to the third red button. Do fear of speaking differ by multiple groups? That is, more than two. Which of these could impersonate groups? I guess education would be a good one. So let's select our variable as education. Do we want to display the means? Well, not really. You could do post hoc tests to see where the differences lie among the 6 levels of education. I'm not going to ask you to do that. So you click on OK. You get down here at the bottom of the screen. Doesn't look too complicated. It says the effect of education on fear of speaking is such that F, which is your test statistic for an ANOVA, is equal to 1.31 if you round the hundreds. And the P is 0.29. That's not a very low value for P. You want low values for the probability of making a type 1 error. So you know that there's no difference among the participants based on education. And here's a sample sentence for that. Please note where I got the numbers for degrees of freedom. They came from the 4th column of the report table at the bottom of the screen. I have all the answers. I will compare your answers from Brightstat to my answers to see if you did it correctly. The good news is, if you're confused, you can rewatch this video over and over and over again. Thanks for watching.